Welcome back. This unit is dedicated to a deep analysis of which are the processes that allows us to store electrical energy directly into chemicals based on hydrogen. We describe the process that allows us to get from the solar energy direct renewable electricity going through solar panels or wind turbines. With renewable electricity, one of the most interesting process to store energy is to produce chemicals. Chemicals mainly based on hydrogen that are called, in general, solar fuels. Sun is the base energy that is supplied to the Earth, and the idea is to activate a closed loop process, a process that is based on water that is electrolyzed through an electrochemical reactor that is usually electrochemical electrolysis device. The product of the electrolysis device are oxygen and hydrogen. Hydrogen is a stable chemical that can be stored with several different solutions, and once a user requires energy in forms of electricity or any other kind of energy, we can implement power system that can be both traditional ones or, much more interesting, fuel cells that will produce the energy required by the user. Oxidizing hydrogen with oxygen and giving so the energy related to this chemical process. The output of this system is water or steam that can be released in atmosphere and used to feed back any electrochemical device to produce hydrogen and oxygen. We can make a step further. We can start from the same solution that is an electrolyzer producing hydrogen and oxygen, but instead of storing into hydrogen with related problems of energy densities, we can try to get higher energy density storage system based on chemicals. So we can implement a process that is called fuel synthesis. In this case, we can have a mixture of hydrogen and carbon dioxide to produce a fuel similar to what is already the fuel used in energy systems. So chemical based on hydrogen and carbon like methane or more complex chemicals like diesel or gasoline. From this process, we usually have as a byproduct steam or water. Such solution allows us to improve the energy density and to transport the energy. Moreover, we can implement this technology into the already existing fuel network. As a result, we can have a technical solution in energy systems based on traditional or innovative technology to provide energy to the users. The output of this process that usually use oxygen taken from atmosphere is again carbon dioxide and hydrogen. The result is that we can close both water and carbon dioxide cycle, water and oxygen cycles. All these three allows us to move energy in a very efficient way from solar energy to the user request. In this unit, in particular, we will go a little bit deep on what is the coupling between the process of hydrogen production and fuel synthesis. Those processes usually start from two chemicals and elements available in nature. Carbon dioxide, that can be obtained from several sources like biomass, but also from atmosphere, and water. Electrical energy is stored through an electrochemical reactor. In this device, electricity is used to transform the base chemicals into chemicals that is energy full, like, for example, hydrogen and carbon monoxide. The product that we usually use can be a mixture of these new chemicals, carbon and monoxide and hydrogen, plus the previous one that still remain in the product as product of the process, like water or steam in this case usually, and carbon dioxide. This gas mixture is called syngas. So syngas is the main input to the chemical process to produce fuels. But syngas is at the same time the main process in which the main chemicals in which we store the electrical energy. Following path is mainly destined to produce a more suitable and transportable mixture. So syngas is the input of all our process. The process usually passes through a chemical reactor. Chemical reactor where we can optimize temperature, pressures, and we can place specific catalytic material to enhance one or another reaction. The aim, anytime, is to get a specific kind of product. For example, we can optimize one process that is called water-gas shift. In this case, the syngas input will be optimized to get carbon monoxide and steam that react to have carbon dioxide and hydrogen. So in this case, we can increase the amount of hydrogen in syngas compounds. But we may have also a different aim and try to optimize the reverse process that is called reverse water-gas shift. In this case, we need to feed to our reactor carbon dioxide and hydrogen, and we may be interested in to produce carbon monoxide and water. Here again, water is a byproduct that can be released to the atmosphere. Another interesting process is what is called the Sabatier. In this case, the product that we want to produce is methane. Methane is pretty interesting because we can use it and in many energy systems, or introduce it in the natural gas network so that we can improve the amount of sustainability of an existing network. So the process involves carbon dioxide and hydrogen and produce methane and steam as a byproduct. With a similar process, we can produce methane starting from carbon monoxide and hydrogen. In this case, we call Methanation Reactor, and with different, of course, optimization of reactor process, we can produce methane, again, to be introduced in the natural gas line, and steam as a byproduct. A more complex process allows us to produce methanol. In this case, we usually feed the reactor with carbon dioxide and hydrogen. It's pretty interesting because in this case we have a high density liquid product that is methanol, and we have as a byproduct water or steam. Finally, we can have a more complex process that is called Fischer-Tropsch. In this case, we can optimize the syngas composition and the process to get different kind of products that can be optimized to get very high density fuels, such as hexane and paraffines. Hexanes are liquid and paraffines are solid. So we can also obtain hexanes that is a product very similar to gasoline. So we can get gasoline from the sun energy. The byproduct is again steam or water. So in general, we can feed the system with compounds from the environment, that is carbon dioxide and water, that can be fed to the electrochemical reactor, where that is the device where chemical energy is produced and is obtained from electric source obtained from renewable energies. And this product is syngas, that is the input for this fuel synthesis reactor that gives us, depending on the optimization of the process, a gaseous fuel, a liquid fuel, or a solid fuel. All those three are called solar fuels. Thank you.